So we have time on the horizontal axis. And let's say we have position on the vertical axis. And then maybe this blue line is going to be our position. And so if we want the velocity here, velocity is change in position over change in time. So maybe from, if this is position 1 and to position 2, then the velocity is the slope of that line, so that's average velocity there. That's written with a bar over it. The instantaneous velocity would be the derivative, which is the slope of a line tangent to the curve at that instant, which in this case it's a little bit hard to see. I wonder if I can undo that. Probably not. Okay. Normal V is the slope of the line that's tangent to the curve. The average V is change in position over change in time. So I'll go ahead and put, here we have T1, T2, and then this will be S1 and S2. So the average velocity equals change in S over change in T, whereas the instantaneous V equals ds over dt. Okay, so slight difference there, and I'll draw this bigger to see. So an example here, if we want that difference over time for the average velocity and then slope of a point tangent to the curve, something like that for instantaneous. Or if we're starting from this point, instantaneous velocity goes up like that. Or if it's this point, the instantaneous velocity is going that way. So instantaneous velocity changes at every single instant, whereas average is just the average over the whole time frame. So if we know these values, so let's say that I'll go ahead and put some tick marks in here. And we'll say that T1 equals 1 second, T2 equals 2 seconds, and it starts at 0. And then S here we have 1, 2, 3, 4. The actual average velocity here from the interval T equals 1 to T equals 2 is going to be the S2 minus S1 over T2 minus T1. So we have 4 minus 3 over 2 minus 1, 1 over 1 equals 1, which is not necessarily going to be the slope, the instantaneous velocity. So if we actually have an equation for S, let's say maybe there's an ant crawling on the ground, and the ant's position is S of T equals, maybe he's kind of squiggling around a little bit. S of T equals 3 cosine of T plus T meters. So to get the instantaneous velocity, V equals ds dt equals -3 sine of T meters per second. And let's say find average velocity on the interval 0 to 4 seconds. Okay, so the instantaneous velocity would be v of 0 equals -3 times sine of 0, which is just 0. Or v of 4 seconds, which equals -3 times the sine of 4. 2.27. So we see that instantaneous velocity is going to change at every single instant. So v at the beginning of this interval, v at the end of this interval are not the same. Whereas average velocity just gets the whole average. And so we'll say for average velocity, we'll have v bar equals change in position over change in t. So this will be s of 4 minus s of 0 over 4 minus 0. So to get the average velocity, we have to actually plug in the values for position and find that. So s of 0, if we plug in 0 for t, we get 3 times cosine of 0, which is just 3, plus 0. S of 0 equals 3 meters. S of 4 equals, we have 3 times cosine of 4 plus 4. .04. So now we take that S of 0 and the S of 4 and we plug it in up here. 2.04 minus 3 over 4 minus 0. So now find the average velocity on that interval. Plug that in and type into chat, what do you get? Oh, I see, -3 sine t plus 1. Okay, good. Peter got that extra point. We'll go ahead and, okay, plus 1. So that would come out to be 1. And so that affects the instantaneous. It does not affect the average. And so this will be now 3.27. Okay, very good catch. And Peter will get an extra point for that. Okay, so if you have an answer now for average V, put it into the chat. All right, -0.24. Very good. -0.24 meters per second. Okay, so this is actually a really interesting situation here because the velocity at 0 was positive. The velocity at 4 was positive. The average velocity ends up being a little bit negative, and that's probably because of the sinusoidal thing. So you know that with a, and actually it's going to look pretty much very similar to the this function that we've already written here. So looking at the way that a sinusoid works, it goes up, it goes down, it goes up again. So if you were to look at the instantaneous velocity, say right here, that would be positive because the function is increasing. And then right here, that would be positive because the function is increasing. Positive V, positive V. But if you look at the position that it took along the whole path, you're pretty much at the same height as you were before. So the average velocity is about 0 because you went up, but then you went back down. And so while the instantaneous velocity tells you your speed at one particular instant, your average velocity tells you your speed over the whole interval. So those two things do not have to be the same at all. So average velocity there. Okay, and then real quick, average acceleration equals change in velocity over change in time. You would do it the same way as you did for V, except you would have V final minus V initial over T final minus T initial. So write down those formulas for average velocity and acceleration because those will be on the test.